Hola, buenas tardes. Gracias por las charlas. Quería hacer una pregunta sobre la familia John. Quería hacer una pregunta sobre la familia que nos has enseñado, donde las...
Sorry, could you repeat the question?
I didn't make it yet. La familia que nos has enseñado, donde las mujeres no eran portadoras, pero sí tenían clínica o something like that. It was a picture of the family, and it was a female that they were the breast, but they had no mutation. Oh. Have you performed this X chromosome inactivation?
Yes. So the mother who. So the mother who was a carrier, but affected only with depression. Yes, we performed X inactivation on her and one of her daughters. We saw some skewing in her daughter, but not in the mother. So that wasn't the answer. That we couldn't find an explanation, but then a lot of people will tell you that what you see in X inactivation patterns in the blood may be different from what you see in the brain. So it would have been nice if there had been some clear evidence of skewing, but unfortunately not. But can I just point out that the two, I don't think I mentioned this, the two brothers who had schizophrenia but didn't carry the mutation, they had no cognitive regression, and their schizophrenia began in late teens of 1920, which is more typical for schizophrenia. The affected individuals who had the mutation and showed psychosis, they all had this very early onset regression, very early onset of psychosis. It's a very sort of dichotomous situation in the family.
And have you checked if it was another gene mutated?
We have. We couldn't find anything, but then not enough is really known about schizophrenia. We hoped perhaps we could find something in common between those two brothers. We know that there's a lot more psychiatric illness in the broader family, but it's difficult getting information, difficult getting blood samples for DNA, and consent, obviously.
Thank you.
Also a question regarding this family, because this clinical picture of early regression and then psychosis is quite uncommon. So was this regression just for some particular period of time, or was a progressive regression, so that they were impairing progressively, or just for a particular period of time?
It's kind of hard to say because they've never really been followed up. So the reports we get are anecdotal. But having said that, the level of regression currently is still at considered very mild.
Okay.
It's just when they were around age 9, the girls just stopped kind of functioning, stopped learning at school. They just were unable to progress any further.
Yeah, because this is quite uncommon in pediatric neurology. Yeah. So when you have patients with these symptoms, normally you are this disease is a neurodegenerative disease, and then the progression goes on and on. So it is like something to an important key for clinicians to remember and maybe to look for this gene.
So this family was part of a larger study of Pakistani families with intellectual disability. I think we had 192, mostly Pakistani, some Iranian families. One of our biggest difficulties is getting good clinical data, and again being able to follow up. So that's what we'd like to do. I hope in the future we are able to follow up this family more.
Okay.
Thank you. This is a question for Dr. Vincent again. I'd like to discuss with you the proline and the arginine mutations. Proline is an atypical amino acid. It's a cyclic amino acid, so I'm not surprised that mutating a proline into any other amino acids would change the structure at some point of the protein. So I'm not surprised that we don't see any loss in affinity with the DNA, but I wonder if maybe we'll lose some affinity with another partner in somewhere else. And for the arginine mutation, the arginine 190 into cysteine, you said that there is maybe an issue with the charge, but I wonder if introducing cysteine would not create disulfide bridges internally into the protein, leading to a funny folding, or even create dimerization with another protein and creating issues.
That's an excellent theory regarding the R190 cysteine mutation. Regarding the proline, we were just looking at the kind of clustering defect, the compaction defect, but this compaction is likely to involve other proteins binding with MECP2, and we are hoping to explore that more, but we just haven't got there yet.
Hola. En el estudio de la conducta de ratones, ¿hay manera de diferenciar la selección natural? Normalmente los animales, cuando tienen problemas con sus crías, los abandonan por cuestión de supervivencia. ¿Hay alguna manera de diferenciar con los estudios si ese abandono de la madre es por esa causa o por la mutación?
Yeah, interesting question. So you're asking about the mice, the mother, the dams abandoning their pups, and if there's an evolutionary selection for that. It's an interesting question. I think in the case of the cross-fostering, though, these are mothers whose own pups have been taken away, and you've replaced them, and they don't seem to care that they're mutant, and they don't abandon them. So I think it's a combination. Definitely there's something, some of these inbred mouse strains have gotten a little odd, and I think the black 6 have many other genetic models on that, also have, pup lethality because of maternal care problems. But there's something particularly striking in the MECP2, and even though we also see this in the bird line, our E1 line was so bad we had to redirect, we couldn't breed the mice for this reason. So I think it's a very interesting question. We try to think like a mouse when we're doing these behavioral experiments, and it could be that in the wild these mice would just die. But there's something. Why would a CD1 mother take them up and take good care of them? And it's ironic too, because even though she is taking what you would say would be better care of them, the mutants in many of the tests were actually worse. So yeah, there's a lot of unexplained parts of this, but I think it's interesting. I think it's more proof of principle that we can modify the environment and actually take all of the mouse models of MECP2 are coming from mutant dams. So we've never really been able to do a good experiment to separate the genetic from the non-genetic parts of that transmission. So that's part of our goal too.
Sí, yo referente al modelo también de cross-fostering, ¿habéis probado que el padre sea el mutante y ver si las crías también tienen problemas o mejoran al cambiar a CD1? Luego, ¿habéis mirado si el cross-fostering mejora a machos MECP2? Y luego, si teniendo en cuenta que los ratones negros ya son por sí malos cuidadores, comparándolo con los ratones blancos, los CD1, que ya por sí tienen un incremento en la conducta materna y tienen una mayor camadas mucho más grandes también incluso. ¿Habéis mirado si las hembras MECP2 generan algún cambio en crías wild type, si el cross-fostering al revés?
Okay, yes, there were several questions. I'm going to take the last one first because you asked about the wild-type pups to the mutant. Yeah, and so we did, I think I showed that in a couple of those bars, that the reason we were able to see the mutant effect in the fostered was because the wild-type pups were actually better off. So although, again, the best controls when you are using the mutant dams as biological dams is the wild-type pups, and that's why everybody uses the litter mates. That controls for the environment, but it doesn't control for the gene by environment interaction. So I think that's why we are seeing this effect. Both we see an improvement in the wild-type pups under the foster dams, and we see this gene by environment interaction in the mutant animals away from their mutant dams. Okay, so then you had a couple other questions in there. I'm remembering, let's see.
The father.
Oh, the father, yes, great question. So no, the problem is because the males are so affected, you can't breed, you can't use the males to breed. We'd like to try, we do have some sperm frozen down, so we're going to try doing the in vitro fertilization and implantation model that way. But really, other than almost all of the models, except for like the Cree models where you can take out MECP2 later in life, all of the current MECP2 mutant models are coming from a mutant dam. It's just the necessity of this model. But again, like I'm saying, in humans, that's not what you see, right? I mean, there are rare cases where, again, the mother that had favorable skew gene activation would pass it on to a girl with Rett syndrome, but those are fairly rare cases, and most of the mutations come from the father in humans. Did I answer all of your questions?
No sé si me sabré explicar. El autismo en un principio estaba en red. Bueno, en mi caso, mi hermana tiene una niña autista y yo red. Hermana y hermanos doble, ¿no? Perdón. Estamos casados 2 hermanos con 2 hermanas. ¿Hay algo vinculado a eso? Si saben algo. ¿O hay mutación en el autismo? Si no, nada.
I think it's...
Si no, nada y muchas gracias.
So you have a daughter with Rett syndrome. Just to clarify.
Sí.
You have a daughter with Rett syndrome and a child with autism.
Una sobrina con autismo, pero mi hermana es mi cuñada.
Okay. Okay.
Sí. Sí.
Sí. Entiendo.
Sí.
Okay.
2 hermanos casada con 2 hermanas.
I don't think there is any connection, no. Unless
Vale.
the only connection. No, I really couldn't see any connection unless there's some mosaicism, perhaps in the family, but I think that's possible. No.
Well, I mean, there could be genetic modifiers.
Is it?
I think someone mentioned genetic modifiers too. So in addition, there could be a modifier in, your daughter that is, shared, but it wouldn't be the MECP2 mutation. But there could be both, again, I think with all of these, even in a monogenic disorder, you can have other genetic modifiers and environmental modifiers that could make a difference. But I don't.
¿Qué tal? Buenas tardes. Tengo 2 preguntas. Una es, ustedes hablan aquí de mutación, que le hacen la prueba de mutación a los padres. Cuando a mi hija le hicieron la prueba de mutación, nada más se le hicieron a ella. ¿Qué es lo que buscan ustedes cuando le hacen la mutación a los padres? ¿Se la debemos de hacer o sea, sirve para el estudio científico?
Sí. I think where, for the majority of Rett mutations, as we know, the mutations are de novo, but where there's a milder phenotype or a phenotype where you're not sure there's a connection with the genotype, then I think it is very important to know if the mutation is inherited. If it's de novo, then it's often more convincing. If it's inherited from the father is unaffected, then it's also convincing, but in the other direction. It's convincing as false positive. Does that make sense?
Sí, claro. Y la otra pregunta es, mi hija tiene la mutación P152R. Has hablado de ella, pero de niños. ¿Qué podemos esperar nosotros? Digo, evidentemente hay miles, que era lo que nos explicaba el doctor Percy hace rato. Pero en general, ¿qué podemos esperar de esta mutación? Entiendo que no es tan grave, pero ¿qué es lo que podemos esperar o qué es?
En el futuro.
So that the proline 152 arginine is one of the common mutations in girls. What was really unusual was the other two mutations, proline 152 histidine, proline 152 alanine. But the assays that we were looking at showed that mutations in different parts of the methyl binding domain have different cellular phenotypes. So some seem to affect the way the protein binds to the DNA, but others seem to affect the way the protein is clustering chromatin in the nucleus, and that may involve other protein MECP2 protein interactions. So what I may suggest is that perhaps not for gene therapy, but for other sort of targets of therapy, there may be therapies that target the DNA binding for mutations such as threonine 158 methionine, or therapies that target the chromatin clustering mutations such as proline 152 arginine.
Okay. Gracias.
¿Alguna pregunta más? Sí.
Sí, buenas tardes. Me ha parecido entender que en síndrome de Rett hay un exceso de desacetilación de la histona. O igual he entendido mal. Hay un exceso de desacetilación de la histona en síndrome de Rett.
I think there's actually an increase there's an increase in acetylation. Because one of the binding partners of MECP2 is histone deacetylase, so you actually do see an increase in histone acetylation. Was that your question?
¿Y se puede intervenir en esa desacetilación? ¿Se puede intervenir con alguna sustancia que inhiba? Igual es una pregunta un poco ingenua, pero ¿existen inhibidores de la desacetilación de las histonas?
I'm not an expert. I know that there are many histone deacetylase, and there's a lot of interest in this in pharmaceutical companies. Valproic acid is one that has been
Sí,
used.
a eso me refiero.
Yes, so that's one that's been used clinically quite a bit, and I know that there are a whole panel of these that have been looked at, but I'm not aware of any that are moving towards clinical trials in Rett syndrome. But it's a great idea. I mean, it's interesting to target the epigenetics potentially that's altered in Rett syndrome.
Sí, perdón. Es que yo tengo una hija con síndrome de Rett que ha mejorado con ácido valproico y pensábamos que igual podía ser porque se ha desactivado la desacetilación. Ella utilizaba el ácido valproico para unas crisis que comenzó a tener, lo dejó de utilizar al desaparecer las crisis y al volver a tener crisis, otra vez utilizó el ácido valproico. Y entonces eso resultó en una mejora de su estado general. De otros parámetros a medir, pues como la ansiedad, los miedos.
I think this would definitely be a question for a clinician. So,
Vale.
talking
Gracias. Perdón. Sí. En síndrome de Rett, bueno, por un hallazgo casual, por una mejora casual en la enfermedad de mi hija con la utilización del ácido valproico, hemos pensado que igual el ácido valproico, al intervenir como inhibidor de la desacetilación de la histona, podría ser un medicamento a utilizar no solamente para combatir las crisis de epilepsia, sino también para mejorar otros parámetros en la conducta de estas chicas.
I agree with what's been said. I'm not aware of any study looking at specifically at histone deacetylase, acetylation. Now, the one question I have, when they used valproic acid, did it improve her seizures?
La crisis, sí. Mejoró la crisis cuando era pequeña, con 6 años. Entonces estuvo un tiempo sin crisis y dejamos de utilizar durante bastantes años el ácido valproico. Volvió a tener una crisis y entonces volvimos a utilizar el ácido valproico y mejoró el tema de la espasticidad, las conductas de miedo y ansiedad. Y lo asociamos al ácido valproico.
And that's true. Valproic acid also has proponents who use it for mood stabilization. So in addition to being an anti-epileptic compound, it also works for mood stabilization or improvement in mood, and has been used, I think, by some psychiatrists for that purpose, independent of its potential effect for seizures. There are a number of other medications, including anti-epileptic medications, that are mood stabilizers, and they are used by psychiatrists for that purpose. So I think the part you have to separate is whether the valproic acid was indeed improving mood from that point of view, or if it was actually improving the histone deacetylase. And I am not knowledgeable enough about methods for measurement, but can you assess histone deacetylase? Sure. Acetylation? Yeah, so I think that would be an answer that you could perhaps find someone who did that and look at histone deacetylation. Now, is she still taking the valproic acid?
Sí.
Yeah, it would be required that you take her off of it.
Sí,
but,
claro.
You probably don't want to do that, and I understand that.
No se lo voy a quitar. Gracias.
¿Alguna pregunta más? Bueno, ya parece que no hay preguntas. Y a mí, si me permitís, aunque sea dilatar un poquito esta mesa, sí me gustaría hacer una pregunta al hilo de un planteamiento que ha hecho Janine, que nos ha hablado de que una vía interesante a explorar podría ser el red y la microbiota intestinal. Todos sabemos que hay una serie de aminoácidos que son esenciales, otros que no son esenciales, y los aminoácidos esenciales hay que aportarlos a través de la dieta, es decir, el entorno tiene ahí una influencia esencial. No sé si hay algún tipo de estudio realizado entre la interrelación que ha podido tener una dieta con determinadas carencias y este tipo de alteraciones que estamos viendo en el síndrome de Rett.
I may ask Alan on this. She was asking about the gut microbiome and diet, and sorry, Alan, but I know I was talking at lunch with you, and you have some information to share with us, but. I think she was asking about, maybe the gut microbiome and so in relation to the constipation and essential amino acids, and what studies are being done on that?
So we don't have any really solid information yet. We're simply collecting samples looking at mother-daughter pairs. So mother as a sort of control for the microbiome of the daughter. A similar study is being done at Baylor College of Medicine, and they are looking at the microbiome and, in addition, looking at another parameter that escapes me right now. But I think these studies have gained interest and traction in the community, and we are looking at them, and I would just expect that results are going to come out in the next year or two. I can tell you that at UAB, where the microbiome study is being done, they have parallel information already from the mouse model or the rat model. I think it's the rat model. So there would be an interesting comparison between the human and the animal model to see if they make any relationship. I think it's an important question to answer regarding essential amino acids or other compounds which may occur in the microbiome of the affected individual that could alter their health, their behavior, the response to the disorder.
Muchísimas gracias. Y bueno, pues como ahora tenemos la presentación del libro de relatos, pues yo creo que ya debemos cerrar esta jornada, que ha sido por otra parte muy intensa. Muchas gracias a todos.